Alright guys, I'm going to be working through your test review. I'm going to put timestamps down at the bottom so you can go ahead and see when I start each problem. Alright, so problem number 1 here, what are the minor arcs? Minor arc, remember, is less than 180 degrees, so we have MN is a minor arc, and we have LP, which is a minor arc. Alright, students usually have no problem finding those two. What you have to remember here is that PN is also a minor arc because it is less than 180 degrees. Same thing with LM. Okay, so those are my 4 minor arcs in this picture. Okay, this one asks for the major arcs of circle O that contain point J. So here's point J. Remember, I have to go more than 180 degrees. HK is the diameter, so that's 180. So I'm going to start here at L, and I'm going to go around all the way to K. And so if I do that, my major arc will be LJK. Remember, with major arcs and semicircles, we use 3 letters. Okay. Identify a semicircle that contains C. Again, it's the same idea. I'm going to start at A. I'm going to go to B because that is my diameter. And here, I'm going to just go ahead and list it as A, C, B to make sure I'm using the semicircle that contains C. If I go the other way, it will not contain C. Okay. Go ahead and move to the second page. We want to name the major arc and find its measure this time. So the major arc is going to be from A to D to B, right? So it's going to be this arc, ADB, right? And we know here that this is 50 degrees. It would help to know what this angle is. So we know that's just going to be 360 minus 50, which is 310 degrees. All right, so the measure of arc ADB is equal to 310 degrees. All right. Find the measure of arc DEA. So here's D, here's A. I'm going to go from D to E to A. The central angle here goes through these two, so it's just going to be a matter of doing 103 plus 27, which is 130 degrees. Okay. Find the circumference. Leave your answer in terms of pi. So we have 2 formulas for circumference. We have circumference equals 2 pi r. But we talked about how this is multiplication and this is commutative, so I can rewrite it as 2r pi. And then we know it's associative, so I can put 2r together, so it's also known as d times pi, or pi d. Since they've given us the diameter is 4.6, I'm going to use this formula, pi d, and so the circumference will equal 4.6 pi centimeters, and that's in terms of pi. Find the length of arc YPX. So here I want to know the length of this arc, right, YPX. So to figure out the length, I'm going to have to know this central angle. Since I know it's 360 less 90, it's going to be 270 degrees. So for this one, we use the measure of the arc, right? So measure of arc YPX over 360 times the circumference, which is 2 pi r. I'm using 2 pi r because I can see the radius right there is 10. Right? So this is going to be 270 over 360 times 2 times pi times 10. 270 over 360, well, that's 3/4 of the circle. So this is 3/4. 2 times 10 is 20 times pi. And 3/4 of 20 is 15. So this is 15 pi, and of course the units will be meters squared. I'm sorry, meters, because we're just doing a linear measurement. Okay. Now we want to find the area of the circle in terms of pi. So we know area is equal to pi r squared. And again, it says leave in terms of pi. So here I'm going to go ahead and I realize that if the diameter is 4.6, the radius is going to be 2.3. So it's going to be pi times 2.3 squared. Okay. So here I'll go ahead and take a quick look at my calculator. Just to make 2.3 squared a little bit easier, I go ahead here and I do 2.3 squared, and I get 5.29 pi. So this equals 5.29 pi, and that'll be meters squared, because this one is area. Okay. The area of a sector with a central angle of 130 degrees and a diameter of 7.4 centimeters, round to the nearest tenth. So notice this one does not say in terms of pi, it says round to the nearest tenth. So I'm actually going to multiply this out. So again, my formula is going to be the measure of the central angle, 130 over 360 times pi, and then the radius is going to be half of 7.4, which is 3.7. So 3.7 squared. Now, since I'm going to be rounding this one, I can actually just go ahead and type this in my calculator pretty much as it appears. So I'll do 130 divided by 360 times pi times 3.7 squared. All right, and I end up with 15.5. The 3 tells me to keep that a 5, so I'll put 15.5 and then centimeters squared, because it's an area. Okay. Find the area of the figure to the nearest tenth. Again, this is the same thing, so I'll do 165 out of 360 times pi times 7 squared. Again, round to the nearest tenth, so I'm actually going to multiply this out. Just so you do 165 divided by 360. Then you can multiply that times pi. And then I can multiply that times 7 squared, which is 49, right? And I end up with 70.55. The 5 tells me to bump that up to a 6. So it'll be 70.6 inches squared. Okay? Pretty straightforward so far. We're on to page 4 here. So here, determine whether a tangent line to circle O is shown in the diagram if AB is equal to 5.2. So I'm going to label my diagram. OB is equal to 3.9. And AO is equal to 6.5. Okay? The right angle, remember the point of tangency is where the tangent touches the radius. And that's going to be right there. So that's where I'm assuming the right angle is. Also, it's the longest side is the hypotenuse. So I'm going to set this up as 5.2 squared plus 3.9 squared equals 6.5 squared. And again, my calculator will help me out here. I'll go ahead and do 5.2 squared plus 3.9 squared. I get 42.25. And then over here I'll do 6.5 squared. And I get 42.25. Since these lengths satisfy the Pythagorean theorem, that means that this is in fact a right angle. Therefore I know that this is a tangent. So yes. And your explanation is really this math right here. That's your explanation. Okay. Here they tell me AB is tangent to circle O. So if I know AB is a tangent, I'm going to immediately go ahead and put in my right angle right there. They tell me that AB is equal to 7. And they tell me that AO is 9.1. So again, I can see that this is my hypotenuse, right? Remember that arrow will always point at the hypotenuse. So here I'll set up my equation as being r squared plus 7 squared equals 9.1 squared. That'll be r squared plus 49. And I'll use my calculator. I mean, I have it. I might as well. So 9.1 squared is 82.81. I'll subtract 49, so it shouldn't be 4.9, it should just be 49. So subtract 49 from each side. And again, on my calculator, it's minus 49, right? Keep life simple. I get 33.81. So r squared is equal to 33.81. I'll now take the square root of each side. And I can do second square root. And then check this out, if you hit second and the negative sign, it populates your previous answer. And I get 5.8 because I'm rounding to the nearest tenth. So the radius is 5.8. Since there's no units, you don't have to worry about it. Just put 5.8. Okay. This one, we're now shifting gears, and we're taking a look at an angle outside. We know when we're looking at an angle outside, right? First of all, it's got that degree mark, right? We know it's going to be big arc minus little arc divided by 2 is equal to the angle, right? We've talked about that relationship quite a few times. Now they tell me here that this angle is 123, so I know that this little arc here must be 123. To find the big arc, I'll do 360 minus 123, right? I get 240, 237. Right? So 237 is my big arc, right here, 237, minus my little arc, 123, divided by 2. 237 minus 123 is going to be 114. Divided by 2 is 57. So I know that that angle is 57 degrees. All right. Moving on to page 5 here, we want to find the measure of angle P is equal to 29. And we're told to assume these are tangents, so I know that this is 90, and I'm asked to find x. If this is 90 degrees, I know the two acute angles of a right angle add up to 90. So I'll go ahead and just do 90 minus 29, and I get 61 degrees. Pretty easy. Okay. Here we have all of these tangent lines in the circle. We're told that JA is 14. So if this is 14, I now know that this is 14 because they're congruent, right? AL is 11, so I know this is 11. This must also be 11. And I'm told that CK is 7. So if this is 7, I know that BK is 7. All right, there should be 2 lines there. All right, so now I just add these all together. 14 and 14 is 28. 7 and 7 is 14. 11 and 11 is 22. 28 and 22 is 50. 50 and 14 is 64. So the perimeter is 64 units. Again, don't worry about that since there's no dimensions there. And then finally we have AB is tangent to circle O. So again, I'm just going to immediately put in my right angle. Right? If AO is 24 and BC is 50, right, what is AB? We can call that one X. Now here they tell me BC is 50, but CO I need to know. Because this is a radius and this is a radius, I know that this is 24. So this whole length here must be 74. So now I can set up my Pythagorean theorem. Again, the right angle is pointing at the the hypotenuse. So I'm going to do x squared plus 24 squared equals 50 squared. Okay. We'll go ahead and do x squared plus, I think that's 276, but let's check. I'm sorry, 576. What am I doing here? And I know that 50 squared is 2,500, right? So plus 576 equals 2,500. I'll subtract 576 from each side. I get x squared equals 1,924. And I'll take the square root of that answer. Again, I'm just using my calculator to help me along the way. And I get 43.8. Alright. I'm sorry, 43.9. Okay, I'm rounding to the nearest tenth, even though, I'm sorry, I messed up here. Forgive me. This should have been 74. Let's try that again. Ignore this. X squared plus 24 squared equals 74 squared. That's better. So 74 squared is 5,476. There we go. That's much better. This is 576. I'll subtract 576. I get x squared equals 4,900. I'll take the square root. X equals 70. My apologies. So we know here that AB is equal to 70. Sorry about that. All right. Again, moving right along. Doing very well here. Here we have a chord that is perpendicular to this line that connects to the center. So that immediately tells me that this here is 6.5 and 6.5. I've got this right angle here. It would really help if I had a right triangle. Now what I'm going to do is I'm going to draw another radius in here. These two must be congruent. So if this is x, this is also x. Now I can do Pythagorean theorem again. Right? So 7 squared plus 6.5 squared equals x squared, since x is my hypotenuse. That's 49 plus, and again I apologize, I'm just trying to go quick here so the video is not too long. 4.9. 49 plus 42.25. Right, I add those together. I get 91.25. Alright, this is equal to x squared, equal to x squared. I'll go ahead and take the square root of each side. I find that x is equal to the square root of my previous answer, which is 9.6. It says round to the nearest tenth, so I'm pretty comfortable with that answer. All right. Over here, we have two congruent chords. So if the chords are congruent, we also know that the arcs are congruent, and we also know that the central angles are congruent. So if that's 51, this must also be 51 degrees. Pretty easy. Circle O and circle P are congruent. So what does that tell me? It tells me all of these radii are exactly the same length. And we want to know what we can conclude. So if those radii are the same length, I also know that these arcs are the same length, which means that those major arcs must also be the same length, right? So if we take a look here, arc CAB, unfortunately I don't know that. I don't know anything about that. Arc DF, and arc AC, man, I don't know anything about that either, so I can't use that one. Arc AB is congruent to DE. Yeah, we see that right in our diagram. Arc AB and arc DE, and then D, none of these. Okay, so it looks like it's going to be C. WZ and XR are diameters. WZ and XR are diameters. What that means is that all of these radii are congruent, and I know my semicircles there are going to be 180 degrees. Okay, I want to find the measure of arc ZWX. So I know from ZW here, because that's a diameter, is 180 degrees. I know that XW is 52 degrees. So the whole arc must be 180 plus 52, which is 232 degrees. Okay, pretty straightforward. All right, here's a fun picture. In circle Z, BZ is congruent to FZ. FZ is perpendicular to CA. I'm sorry, BZ is perpendicular to CA. So that makes this a right angle. What that means is that these two are congruent. And furthermore, since they're the same distance, as long as this one's perpendicular, which it tells me it is, I know that these must all be congruent. Now it's going to tell me that DF is 26. I know this is 26, this is 26, this is 26, and this is 26. And ask me what's BC, it's 26. They could have asked me what is AC, and I would have had to double it to get 52, but again, pretty straightforward. The radius of circle O is 19, so OB here is 19. OC, they tell me, is 10, and they're asking me to find AB. So here, I can go ahead, I can figure out what this is. I know it's congruent to this, so I'll just have to double it. So I'll call this X, and I'll go ahead and do Pythagorean theorem again. 10 squared plus X squared equals 19 squared. Okay, so that's 100 plus X squared equals, let's see, 19 squared is 361. On a good day, I'd know that X squared must equal 261. I'm sorry, yeah, 261. I'll take the square root of each side, and I find that X is equal to 19. That's not right. Second, square root of 261. There we go, 16.155, 16.155, ... It just keeps going. Now I know I need to double this, so I'm going to use my calculator. I'm just going to multiply that number times 2. And it gives me 32.3. Make sure you double it before you round, otherwise you might have a rounding error. So I know that AB, which is twice that, is about 32.3 units long. Okay, sorry. Here, we've got these 3 arcs, all right, and we want to go ahead and figure out what the measure of X is. Well, I know those 3 arcs make a circle, so I'm going to add them all together. 6x and 8x is 14x. 14x and 10x is 24x. Negative 10 and plus 10 are going to cancel. So I just get 24x equals 360. I'll divide each side by 24, and I get x equals 15. Now I actually have to plug that back in to see what type of triangle this is, right? So here I'm going to do 6x times 15 is 90, and because angle Q opens up to this arc PR, I know that it's going to be half of that's going to be 45 degrees. Here 10x plus 10, that's going to be 150 plus 10, that's 160 degrees. So if I cut that in half, I know that this arc is 80 degrees. I'm sorry, this angle is 80 degrees. And then finally for the last one, 8 times 15 is 120, minus 10 is 110, and if I cut that in half, I get 55 degrees. Now here, these all add up to 180, which is good, they should, but because none of them are congruent, I know that this is a scalene triangle, right? Because if it was isosceles, 2 of the angles would have to be congruent. If it was equilateral, they would all have to be 60, okay? 24, in circle O, the measure of angle R is 32 degrees. So this is 32 degrees. What does that make this arc? Well, it opens up to this arc, so it must be twice as big at 64 degrees. Find the measure of angle O. This is a central angle, So it's equal to the arc it opens up to, which is 64. So I know that it is 64 degrees. Okay. Find x in circle O. So this is kind of the same thing here. This is 51 degrees, so the central angle is 51 degrees, but I don't actually even need to know that. I just know that this is an inscribed angle that opens up to 51 degrees, so this is going to be half of 51 degrees, which is 25.5 degrees. All right. Find the measure of angle BAC. So we're looking for this angle here, right? That's our question. So we know here that AC is a diameter, so we know that this is 180. We know that here this is 84. So if this whole thing's 180, and I subtract 84, I figure out that this arc is 96. If this is 96, I cut it in half to get the inscribed angle. I know that that is 48 degrees. Okay. Top of the next page, the measure of arc DE is 110 degrees. The measure of arc BC is 53 degrees, and we want to find this angle on the outside. We know again this is big arc minus little arc divided by 2. 110 minus 53 divided by 2 is 67. Is that right? No, it's 57 divided by 2. It's going to be 20. Man, I'm struggling with this. Half of 56, 25, 28. 28.5 degrees. All right. Ooh, here's a fun diagram. All right, AB is tangent to circle B, right? So we got a tangent here. Measure of angle A is 28. So this is 28 degrees. The measure of arc BC is 86. We know that this arc here is 86 degrees. All right, and we want to go and figure out what X and Y are going to be. Now notice here this angle opens up to these two arcs. So I can go ahead here first and go ahead and say, well, we've got the big arc, 86, minus the little arc, X, divided by 2 must equal 28. I'll go ahead and double each side, and I get 86 minus X is equal to 56. 86, I'll go ahead and add X to each side, and subtract 56 from each side, and I get X equals 30. So I now know that X is 30 degrees. Okay. Now I need to find Y. So I know that this arc is 30 and that arc is 86, and together these three arcs have to make 360. So I'll do 360 minus 30 plus 86 is 116. Alright, looks like we got 84, 144, maybe 244, 244 degrees. Now to find Y, this angle, right, we know is half of this arc. So if that's 244 degrees, I cut that in half and I get 122 degrees. Clearly this picture was not drawn to scale. All right, any questions there? It doesn't matter, I can't hear you. All right, moving on down. CD is tangent to circle O at D. So I know that here this is a tangent, and this is a point of tangency, right? BC is equal to 20. DC is equal to 23. And I want to go ahead and figure out the diameter. So I want to figure out BA, which is X. This is an outside plus inside problem. So here I'm going to do outside of CA, which is 20, times outside plus inside, which is my diameter, X, is going to equal 23 squared, because it's just a tangent. So I get 400 plus 20x is equal to, and again I'll use my calculator to help me out here, 23 squared is 529. I'll go ahead and subtract 400 from each side. I get 20x is equal to 129, and then I'll divide that by 20. So half of 12.9 is 6.45. And when I round that to the nearest tenth, it becomes 6.5. Alright? So again, that one's not too bad. Okay? Outside times outside plus inside. Alright? This is another one where we're going to be taking a look at outside times outside plus inside. So here we have 7 is outside, 17 is inside, so this will be 7 times 7 plus 17 is equal to x squared. 7 plus 17 is 24. 24 times 7 is 168. Oh, so close. All right, we'll go ahead and do the square root of 168. And we get 12.96, which rounds to 13. So x is 13. All right. Thank goodness that's one of my answer choices. Okay. Now here, they're crossing the middle. So remember here, when they cross in the middle, I just multiply down the line. So here, 9 and 15 are on the same line, so I'll do 9 times 15. Right? And then on the other line, I have 8 times x. 9 times 15, that's 135, is equal to 8x, divide each side by 8. And I'll go ahead and do 135 divided by 8. I get 16.875 or 16.9. Okay. All right, here they tell me that AB is 10. They tell me that BC is 10. And they tell me that CD is 9. Clearly not drawing the scale, but that's all right. This is outside times outside plus inside. So 10 times 10 plus 10 equals outside times outside plus inside, 9 times 9 plus x. 10 plus 10 is 20, times 10 is 200. Here I'll distribute. I get 81 plus 9x. I'll subtract 81 from each side. I get 119 is equal to 9x. And I'll go ahead and divide by 9. All right. 9 goes into 11 one time with a remainder of 2. 9 goes into 29 3 times with a remainder of 2. So then that's just going to be 2 9ths repeating, so just 0.2, so 13.2. Again, your calculator can tell you that, I think. Let me double check. 119 divided by 9. Yeah, I crushed it. I'm so good at this. I should be a math teacher. All right. Last page. Oh my goodness, what a strange road it's been. Here we've got AD is 8. Right? We're looking for AB. This is x. All right. So again, here this outside times outside plus inside. So we have x times x plus 12 is equal to 8 squared. Right? So this becomes x squared plus 12x equals 64. We'll subtract 64 from each side because it's a quadratic. Now I need to factor. I need to find two numbers that multiply to give me 64. I'm thinking 16 and 4. So this will be x plus 16 times x minus 4. Right? What makes this one equal 0? Right? Because I need it to equal 0. If I plug negative 16 in here, negative 16 plus 16 is 0. 0 times anything is 0. Here I'll plug in 4. 4 minus 4 is 0. 0 times anything is 0. It's not going to be the negative number. It's got to be the positive number. So I can see here that x is 4. And then finally, we're taking a look here at some angles. So here, find the value of x. We know that arc AB is 35. We know that arc CD is 43. This angle is vertical to this angle, so they must be congruent. So remember, when they intersect inside, I do big arc plus little arc divided by 2 is equal to the angle. Okay? So the big arc, 43, plus the little arc, 35, divided by 2. I get 78 divided by 2 is 39. So x is 39 degrees. All right. If you guys have any questions, please email me early and often, and I will try to help you. I've also uploaded my answer key in pictures to Canvas, so you can look at that. Remember, looking at my answers and my work is not the same as trying a problem and checking your answer to make sure you're doing it right. If you're not doing it right, figure out what I did that you did differently to make sure you're ready for tomorrow's test. All right? Please make sure your iPads are charged for tomorrow. I'm still trying to decide if I'm going to do the test on paper or on Canvas. Either way, there will be a multiple choice component. All right? Please study.